minimum and maximum values of quadratic functions. So our objective here, determine a quadratic function's minimum or maximum value. And we'll do this, we'll see this on the graphing calculator. It's pretty easy to find it from the graph, but we're going to be doing it here algebraically. So what do we know that's going to be helpful? Well, we know what a quadratic function is. It is any function of the form f of x equals ax squared plus bx plus c. A, b, and c are real numbers, and you have to have an you have to have an x squared term, so a can't be 0. And we know that when the function is in general or standard form, and this is the general or the standard form, the vertex is located at negative b over 2a for the x-coordinate, and the function's value at negative b over 2a for the y-coordinate. So this is the x-coordinate of the vertex, and this is the y-coordinate of the vertex. We know what a parabola is, the graph of any quadratic. It is shaped like a bowl, opening up or opening down, depending upon the coefficient of the x squared term, the a. We know that it has a vertex where it makes the turn. The vertex is a minimum if the parabola opens up. The vertex is a maximum if the parabola opens down. And we know that the domain is the set of values, the x values, that can go into a function, and the range is a set of values, the y values, that come out of a function. We're going to make use of all of that stuff in this video. All right. A quadratic's vertex is its minimum or its maximum. Okay, right here we know that. The x-coordinate of the vertex represents where the minimum or maximum is. So where is it? X equals 2, so it's at x equals 2, and it may have units involved. We'll see that in an upcoming video. The y-coordinate of the vertex represents what that minimum or maximum value is. So the x-coordinate along the x-axis tells us where to find the maximum or minimum. The y-coordinate tells us what that maximum or minimum is. Okay, let's do an example. I think it'll become much clearer with an example. And we're going to use our graphing device as well. So example 1, consider the quadratic function f of x is equal to negative 3x squared plus 6x minus 13. Okay, first part, let's determine algebraically whether this function has a minimum value or a maximum value. Well, the coefficient of the x squared term is the letter a in our general form. So here we have a is equal to negative 3. Negative 3 is less than 0. So we know that the parabola is opening down. So the function has a maximum value. Has a max, I'll go ahead and spell out maximum, M-A-X-I-M-U-M, value. Simply put, the parabola is opening down. So there's a pretty kind of, reasonably good drawing. And so its vertex, it has a maximum value. The parabola has a maximum value as determined by its vertex. And that's how it would look. If it opens down, its vertex, it tells you have a maximum value in the parabola. Okay, let me switch some papers here. Get my notes together. Okay. Now, letter B tells us, and I'm going to give myself a little bit of space up top above it there. We want to find this minimum or maximum value, and we want to know where it occurs. Well, this is the what. What is the minimum maximum value? This is the y equals part. okay? Where does it occur, which is explicitly written here, that's the x equals part. Where is it? Well, it's the x coordinate of the vertex. What is it? It's the y coordinate of the vertex. So let's remind ourselves that f of x was equal to negative 3x squared plus 6x minus 13. This is in the standard or general form. And we know that a is equal to negative 3 and b is equal to positive 6. Okay, so the x coordinate of the vertex is equal to negative b over 2a. Well, let's substitute in negative. B is 6, and as you know, I like to use parentheses just to make sure I don't lose negatives. Over 2 times a is negative 3. And so I do the math, negative 6 divided by negative 6. The x coordinate of the vertex is 1. So where does the maximum value occur? At x equals 1. We'll write that down in just a moment. The y coordinate of the vertex, okay, well that's equal to f of negative b over 2a. Well, that's going to be f of 1 because negative b over 2a is 1, so f of 1, which means we need to put 1 into our function. Input 1, what do we get out? We get negative 3 times 1 squared plus 6 times 1 minus 13. I put that into a calculator, and I think I get negative 10. Let me double check. Negative 3 plus 6 is positive 3 minus 13. I get negative 10. Okay, so find the minimum or maximum value. Well, we know we have a maximum because we have a parabola that is opening down. Okay, that value. So the maximum value is the y coordinate. The maximum value is negative 10. So our parabola, I'll come over here to the side. I'll simply draw this. We're at 1, negative 10. So let's see here, we're at 1. So here's my parabola right there. Okay, the vertex is at 1, negative 10. A little off scale, but you get the idea. The maximum value is negative 10, and it occurs at x equals 1. Okay, so again, where is the maximum value? It's located at x equals 1, x-axis. What is the maximum value? That's the y coordinate of the vertex, and the maximum value of this parabola is negative 10. Let's see that on our graphing calculator. So I'll go into my graph, y equals, I've got something in there, I'll clear it out. And my formula is, my function is negative 3x squared plus 6x minus 13. Let's graph that. Looks like I've zoomed in here. Oh, okay, I can zoom, I've zoomed out, it looks like. I have it set up. Let's zoom in a little bit. I'll zoom in, let's see if that shows me the point. Looks like I'm missing it. Looks like negative 10 is right here and I just missed it. So I'll go to my window. I need to capture, how about negative 15? I don't need to go quite as high. Let's try that. There it is, there's my parabola. And I want to know what's that point right there. So let's go to second calculate. I want to calculate that maximum. And I set my parameters. I want to be between there. I set my boundaries and there. And I'll tell it to guess. There you go. X is equal to 1 right here. Y is equal to negative 10. Where is the maximum located? At x equals positive 1. What is the maximum value? Negative 10, the y coordinate. Okay, finally, let's go back and let's remind ourselves about domain and range. We've already got the function here. Okay, I'll redraw it. So I'm in the fourth quadrant. Here is my vertex of 1, -10. And here is my parabola. Nothing fancy, just give me a quick sense. Let me slide it up there for you. There's my parabola. Domain is in this direction. Well, I have no restrictions in that direction. It keeps going down and further toward -infinity that way. Same thing here, it's going down, it's going further and further this way. It's slowly, but it's going there. So my domain in interval notation is from -infinity to infinity. And of course, infinity is always represented with the parentheses. My range is in the y direction this way, and notice I have a hard stop. Okay, so again, my range, I go from bottom to top. So my range, well, from bottom, it's going to -infinity. So -infinity is where I start my range. As I work my way up, let me get my pencil figured out. As I work my way up, I have a hard stop at -10. It's a closed circle, so it's included. So I'll put -10 and I'll enclose that with a square bracket. So this function's domain and range. The domain goes from -infinity to infinity in the x direction. The range goes from -infinity to -10 in the y direction. So there you have it, how to find the minimum and maximum values of a quadratic.